In this video, I'm going to explain what a DNS server is. DNS stands for Domain Name System. Let us consider this oversimplified network that consists of a personal computer, home router, and a DNS server. So when we use our personal computer for web browsing, we usually open up a browser client like Google, Firefox, or Microsoft Edge, and what we do is we type in the website that we want to visit. So if I want to go to example.com and hit enter, basically our computer doesn't know what this website is and where it's located. So what your web browser client does is it initiates a DNS request to find this specific website that you search for on the internet. So from your personal computer, the DNS request will be forwarded to your home router, since it will need to leave the local area network to access the public internet and find the website. So from your home router, it will then be forwarded to a DNS server, and the DNS server gives you the designated IP address of the website that you are searching for. So if example.com has the IP address of 192.168.0.1, it fulfills your request by sending this back to you. So it will send this back to you. There we go. And from your personal computer with your browser client, you can now view the example.com website. Now, obviously, there's a lot more things to discuss here, such as HTTP protocol, TCP, all that good stuff, and like how the home router doesn't usually connect to the DNS server directly, but rather it hops on much more networking devices. But for the sake of simplicity, I just wanted to give a brief explanation of what a DNS server does. So since a DNS server serves the huge role of mapping website host names to IP addresses, this is also the reason why the internet cannot use a single centralized DNS server. Because if every device on the internet were to use this DNS server, what will happen is this DNS server need the computing power to essentially handle the DNS request traffic of every device that is using it. So this can potentially crash it, and this leads us to number two, which is if this single DNS server was to crash, then it will be a single point of failure, and the internet will essentially be unusable for every device that is using it. So another reason is geographical distance. So let's say this host is located in the US and this host is located in Australia. And let's say this DNS server is also located in the US. So what would happen is if this host from Australia was to initiate a DNS request, it will essentially need to travel the other side of the globe to even reach this DNS server, and that can potentially lead to significantly longer response time as compared to someone that is in the same location as the DNS server. Also, just imagine the size of the database that this DNS server will need in order to store every unique hostname to IP address mappings for every websites that are being used by each host. So for example, if this host uses 100 unique websites, then that would mean the DNS server database will store a total of 500 unique hostname to IP address mappings. So as you can see, these are the reasons why having a single centralized DNS server poses a clear scalability issue. So in order to be scalable, DNS servers are distributed globally across different countries, and they use a more spread out and organized structure called the distributed hierarchical database. So what the distributed hierarchical database means is, instead of a single centralized DNS server for the internet to use, DNS servers are distributed all over the world, and they are classified into three kinds of classes, which are the root servers, which is the servers located at the very top here in this hierarchy, and in the middle are called the top layer domain servers. So top layer domain servers. And at the very bottom here, they are called the authoritative DNS servers. So authoritative DNS servers. So let me explain each class briefly. So for the root DNS servers, the very top, there are more than 1,000 root DNS servers all over the world, and they are managed and maintained by different organizations, and they are coordinated through the Internet Assigned Numbers Authority, or IANA. I will provide a link for you guys if you're interested in viewing the organizations that maintain and manage these servers. So for the middle layer or the top layer domain servers, these are the DNS servers that manage the global domains, globally known domains like .com, or country domains like .jp, .uk, .ph, all those kinds of domains. So another thing to note here is that the root DNS servers store the IP addresses of these top layer domain servers. So again, I will provide a website link for you guys to visit if you want to view all the available top layer domain servers and the organizations or companies that manages them. So for authoritative DNS servers, these are the servers that actually hold the website that you want to visit. Or more specifically, these are the servers that knows the specific hostname to IP address mapping of the website from your DNS request. It's also important to note that, similarly to how root DNS servers store the IP addresses of top layer domain servers, top layer domain servers also store the IP addresses of authoritative DNS servers. So there is this thing called a local DNS server, and it may not be located here in this distributed hierarchical database structure, but nevertheless it is crucial to how everything works here in this figure right here. So let me just create a circle here and call it a local DNS server. Local DNS server. So local DNS servers are typically provided by your internet service provider, or ISP, and depending on what they offer, a local DNS server might reside on the same network as you, or your local area network, or it can be located not more than a few routers away from your local area network. So what your local DNS server does is it kind of acts like a holding server for all your DNS requests. So for example, if you were to use your personal computer and make a DNS request, your DNS request is first processed by your local DNS server. And then from your local DNS server, it then throws it to the actual distributed hierarchical database right here. So now let me actually explain how DNS requests are processed in this distributed hierarchical database system. So let us move to this figure. Let's say you are this requesting host and you are looking for this specific website, which is the guide.cs.you-must-edu. So you use your browser client, you type in this website, you hit enter, and what your browser client does is it initiates a DNS request and forwards it to your local DNS server. So your local DNS server doesn't know this website. So what it does is it forwards it to a root DNS server. However, the root DNS server still doesn't know the specific website that you are searching for. However, it looks at the suffix of the website and finds out it's a .edu. So what it does is it instead forwards the IP address of a top layer domain server for .edu to your local DNS server. So now your local DNS server has the IP address to go to that specific top layer domain server. So it goes to this TLD server, and again, it still doesn't know the specific website that you're searching for. So what this TLD DNS server does is it then gives you the IP address of the authoritative DNS server to your local DNS server. So this is take note, this is also the reason why the root DNS server and top layer domain server and the authoritative DNS server keep IP addresses of each servers. So from your local DNS server, what it does is it then forwards it to the authoritative DNS server as given by the top layer domain server. So now the authoritative DNS server is actually the server that does hold the specific hostname to IP address of the website that you are searching for. So what it does is it searches for this and it gives you that specific hostname to IP address mapping. And now from your local DNS server, it then sends it back to your browser client, and now you can view and access the specific website that you searched for. So as you can see, this DNS request process is very much analogous to a phone book system, where if I'm looking for a specific individual and I ask another person, and if that person doesn't know the individual that I'm looking for, what it does instead is it refers me to another person that might potentially know the specific person that I'm searching for, if that makes sense. As an ending, I will say there is a thing called a DNS caching, and I'm just going to type it here. DNS caching. And what it does is it basically simplifies and reduces redundancy in terms of requests and replies in this DNS request system by giving each server the ability to store the hostname to IP address mappings of searched websites. So how exactly does it reduce these redundancies and So what it does is it if, for example, the local DNS server stored the mapping for this website, then if I searched for that website again, the local DNS server now holds the hostname to IP address mapping, so it will then directly send it back to me instead of taking the usual long route. So that's basically what DNS caching does. So that's pretty much it for this video. I hope I explained this topic clearly to you, and that's it. See ya.